Okay, folks, the stage is yours.
All right, thanks a lot. So hi everyone, I'm gonna talk a little bit about the status of the freedesktop.org GitLab cloud hosting. So first, who I am, I'm Benjamin Tissoir. You can find me on IRC with the nickname Bentis, and I'm here because I'm a quite recent freedesktop admin. For what it was, I also work at Red Hat. So before we go too deep into this talk, I would like to explain why we have this talk and why all this work has happened in the previous year, 6 months, 6 to 8 months. So back in February 2020, Daniel Vetter sent out an email on Wayland Devon and on many other mailing lists, stating that basically GitLab has become very popular. So it's a good thing, and it's used extensively. This includes CI integration, modern development process, and tooling. Yay. The bad news, the cost was tremendous, and it's breaking our bank account. And if you go at the end of this email, he mentioned that assuming that we want cash flow reserves for 1 year at GitLab without CI and a trim XDC, which luckily or unluckily we actually had, we would have to cut our CI services somewhere between May and June this year. So this was quite a bad news. This came as a shock for everybody. But if you don't want to look at everything, the TLDR of the talk is that we are in a better shape, we have a plan, and we are managing the cost. So before we go too deep into everything, I would like to explain a little bit about the history of GitLab, why we are using it, and how we are using it, and why we came to this situation. So before December 2017, the situation was not good. I encourage everybody to have a look at this blog post from Daniel Stone, where the gist of it is that there were 3 main problems for it. The hardware that we were using was reaching end of life, so we would have to pay for new hardware at some point. We were running a lot of independent service, independent of each other's. So for instance, we were running SSH, we were running Git, we were running Wiki, we were running Travis, if I remember correctly. And for every single bit of operation, there has to be a manual admin intervention. So that was not good, and the result were that people were actually fleeing freedesktop hosting, which would make the whole project moot. So people started to have a look at it and see how we can get things in a better shape, and basically they decided to use GitLab for the all-in-one integrated solution. So admin do not like to do tiny operation all the time for every user, and GitLab was solving that. Regarding the hardware, GitLab can run on Google Cloud Platform or any cloud provider, so that's really nice because you don't need to have your own hardware, you can just loan it. It integrates everything that we are using. Bugzilla would be there, the code cgit would be there, the wiki would be there too, and the CI would be there, and hopefully a good CI. And the most important thing was that there is no more admin bottlenecks, which means that project leaders in every sub-project within freedesktop are admin on their own project, so they can add, remove people, they can deal with people, everybody can add its own SSH key without having to ask an admin for it. The second good point for that was that GitLab, the corporation, could help Daniel Stone setting things up, so it was really appreciated. Thanks a lot for that. And the third point was that GNOME went through a similar process few months or a year ago, and they were really happy with GitLab and everything that was there. And so that's how we got an initial deployment of GitLab between December 2017 and September 2018. At the very beginning, there was only a few volunteer projects who could deal with some downtime, and so it was spawned first at the very beginning. They were happy with it. Some CI runners were deployed, but they were not very production ready. So we had a lot of try and error with those, but that was fine because they were not very big projects and they were not that in need for CI all the time. The interesting part was that given all of the SPI infrastructure, it was directly built on Daniel's own bank account, but in the end it was reimbursed by GitLab for the beginning. And given that, the costs were reasonable and they were monitored because it was coming out directly from Daniel's bank account. If you want to have a look at the cost at that period, we were roughly between 300 and 400 a month. So that was definitely reasonable. And so, yeah, GitLab was not costing FreeDesktop a lot of money. Then came SPI. SPI managed to get built directly, and coincidentally, we actually beefed up the instance because some other projects were there. So we grow in the cost, but that was fine. There were reasons for it, and again, it was fine. So new project were added, Think Meta. Meta started to use it extensively. The CI started to kick in. So yes, more usage of GitLab. But even if we were in between 2,000 a month, that was the yearly estimate of the cost of GitLab. Initially, I think the cost, we thought that the cost would be between 15 to 20K with a little bit of margin. But also, if you look at this, it was also partly reimbursed by GitLab, and thanks a lot. They gave us 9K in total, so that was really appreciated, and that helped us setting up things up. But then, if you look between November and 2018 to November 2019, the costs were slightly hidden by the 30K grant from Google. So basically, we went to Google, or Google came to us, and they gave us a 30K grant to run on Google Cloud Platform. So that was really nice for them. But that came also with a trick. The trick was that it completely hid the costs between April, when we started to have the grant, and November, when we actually started to have finished the money that we had in the grant. So basically, what happened is that between November 2018 and November 2019, we thought that we were still in the yearly estimates of what we thought GitLab would cost. When November came in, the first bill was almost 4,000. That was a little bit more than what we had 6 months ago, but that was still fine. I mean, that's not good, but that's fine. But then December, January came, and we were roughly at 6,000, and that was way too much. And that's when Daniel sent out the email. So what happened? If we did not have this 30K grant from Google, basically this is what we would have seen. We would have detected that the growth was exponential. We were using more and more the cloud, and the costs were piling up every month. And so the blue line there is an exponential regression. And so you can see that it was completely out of control and nobody was actually watching it. So once we realized that we have to do something, we have to analyze the situation, we have to understand. And so how do we get to 6,300 bill a month for Google Cloud? So I don't know if anybody listening to the stream had ever had a cloud bill, but it's really complex to get through it. So this is an extract. It's actually more condensed of what you got on your bill because I summarized everything as a table. But you've got all of these objects and you don't know what you're paying for, basically. So let me give you a little bit of hint. Let me split it in three. The green one is the networking cost. The red one is the compute cost, the hardware choices, and the white one is the Kubernetes cost. So I don't ask anybody to have a look at the actual numbers and whatnot, but just that it's quite complex to get something out of it. So if you look at the breakdown, we would have a networking cost of 3,700 for January to 2020. That's a lot. And basically, we do not know where this networking cost came from and where they were going to. The compute costs were a little bit more reasonable because these are the hardware choices that we made. To be able to have a reactive GitLab and a good server, we had to make hardware choices, and this was basically this 2,300 a month. The Kubernetes costs are something that you have to pay for it. It's mainly logging, cloud storage, and some various things. So that's how you get to 6,000 a month. The problem is the networking cost. This is something that we did not anticipate, that nobody anticipated, and it was like the big surprise. So to be able to split that bill, to understand it, you have to split by product. There are actually two products involved in networking. One is the cloud storage for 1,600, and one is the compute engine for 2,000 a month. So if you want to have a look at it later, by the way, the slides are already uploaded if you want to have a look at the numbers. But there are a few cloud definitions with that. Download is quite easy. It's whatever we download something from Google Cloud Platform to the client. The egress is actually download, what they call download in the cloud world. Ingress is the other side, the other way around. So data counted from the client to the compute node. This is free from Google, luckily. And a node is a machine in the cluster. So if we try to analyze a little bit what is the compute engine and what is the cloud storage, the compute engine is basically anything that goes out of gitlab.freedesktop.org, being the web, the Git API, and anything else that is not in the other side. Cloud storage is the everything that comes out from Google Cloud buckets. So these buckets are cloud storage. And these are namely the artifacts, the registry, the large file system, and the uploads. So what could be done at that time to try to reduce the cost? In terms of compute engine, we wanted to have a look at it. The problem was that the current installation that we had local addresses in the logs. So it's kind of hard to know if the data that you are logging is going outside of the Google Cloud Platform if you only have local addresses in logs. So basically, we couldn't do much more at that time regarding compute engine. However, the cloud storage networking costs were something that should be doable to get something out of Google, because it's only Google Cloud storage, and this is a product from Google for I don't know how many years. Unfortunately, the current installation that we had at this time did not have any useful information for us. We could not get any valid information to know which project is using what, and if it was registry, artifact, whatnot. There was, like, we were having a discussion knowing whether it was artifacts or registries, and we didn't know. But there must be a way. So Daniel enabled the logs by running this wonderful command, if you ever want to have a look at the documentation. And this creates a CSV file, which I'm going to show you, just one line, that gives you everything. Every single access to the Google Cloud Storage gets logged. We've got the IP address, we've got the URI, we've got the size that we are putting, and we've got a lot more information. That's very nice. The problem is that every single access to the cloud storage is one line, and you've got 8 files per hour that are all not ordered, and you have to squeeze things back together to be able to provide something interesting. And so that's why Daniel stumbled upon this issue on the free desktop tracker. We have a massive growth in usage, and we need to figure out who to blame for this, so that optimization effort are actually directed where it benefits the most, instead of just wild guesses. First priority was Google Cloud Storage downloads, because that was growing the quickest, and that's also where we could actually have logs. We'd want to be able to assign use network between both two projects to know where to cut artifact size, and to external CI runners lab in order to know where we really need better caching. So basically, where are we? One biggest mistake of my life, probably, something like that. Hey, if it's not too big of a task, I wouldn't mind volunteering to try to get some info out of it. Actually, it's the X.Org way, so as soon as you start doing something, you get admin. And so that's how I got on board. So, regarding, so previously we thought that we need to do something about the cloud storage. So that was a first attempt to reduce the cost. And so the first thing was to do an analysis, and that was actually what I mentioned previously. Provide a Python script to parse the Google logs. So the repository is there. It's on free desktop. You can have a look at it. It's maybe not the greatest Python code ever, but it works. What it does is that it simply parses all of the logs, try to aggregate them together, and store everything in a time series database. If you don't know what a time series database is, it's something where you can put logs and data. And the time series database I'm using is InfluxDB, so that I had to install it on the Google Cloud Platform, of course. For the record, I initially tried Graphite, but it didn't work well enough for us because we wanted to have multiple dimensions for every single log point. But of course, once we publish the data in a database, we need the tool to actually export it. And this tool is called Grafana. Grafana is nice in a way that it's also integrated with GitLab. If you install the product, either the Omnibus install or the native Kubernetes installation, you can have access to it. So we integrated this together, and now we have access to the logs from the Google Cloud Storage directly within our infrastructure. And these are the results for the period of March 2020. If you look at them, you'll see that we are doing huge numbers of traffic, huge data transfer for the artifacts and for the registry. I left out the LFS and the uploads because they were like peanuts in the middle. And what happened is that we were having roughly 50-50 between the artifacts and the registry. So we have to tackle both at the same time. So what can be done for the registry? First, we made a quick analysis on the high registry pools, while we were pulling a lot of registry images all the time. So it was mostly because of the CI. And turns out that the CI runners that we were using were not optimized. First thing that I had was that the RAID on the disk was not configured. So we had small disks. That was not good. The second point that took us a bit more time to actually fix was it was actually hard to do a garbage collector of the image that we are putting, given that the runners are shared for all of the GitLab infrastructure of Redesktop. We are pulling a lot of various random images from everywhere, from every project. And at some point, the disk space goes out and we can't do much about it. So we have to garbage collect the images. But it was kind of hard to do it nicely in a way that we don't delete an image that we will need in a few minutes or a few hours. So we took some steps to do some registry remediations. The first was to actually configure the RAID, which is something which seems evident. And we went from 440 gigs in Slash, so in shared storage, to a dedicated 1.3 terabyte storage per runner for the runners on packet, the runner that the free desktop is actually administering. So that was nice. It has an impact. We will see that on the next slide, but it's still not enough. The second step that we took was to rewrite a new registry image garbage collector, which we called, so Daniel Stoll and I wrote on that. We called it Docker Free Space, and basically it has three main points. It takes the image usage into account. There is a script that scrubs all of the CI scripts that are run, checks for every image that is pulled, and we published that data every hour or something like that. And then whenever we put in, whenever we need to know if an image is used or not, we just grab from that data globally within our whole GitLab instance, and we know if we can trash the image or not. So the idea is that often images are less likely to be deleted. We also implemented some custom label support, which is so you can attach a label to an image, and we implemented two mostly expires after and upstream repo. The important point is that you can set up a pipeline, create a brand new image of it, and say that you don't want the image to be there after 1 day. That's perfectly fine, and the Docker free space will just clear up the image after this 1 day has been done. So that if anybody could use that, that could help us knowing which image are meant to stay for a long time or which are just like temporary ones. And last but not least, we are running on Docker events, and it's not a cron job anymore. The interest is that with the cron job that we had previously, we had to do a lot of manual intervention. Every here and now, some runners were full, and we had to actually go there and free up some space manually. While if we run on Docker event, whenever you start a CI job, it checks for the disk space and run the tools if it needs to. So this is the impact that we saw. You can see that we activated the red second or third week of March, and you can immediately see that the number of registry pool dropped. So that was nice. We were happy for just a week because the week after we were full on disk and we started back to our original registry pools. So we put a hard effort on Docker free space, and we managed to get things sorted out quickly in 2 months. And that was good. We managed to go down from more than 2 terabytes to less than 900 gigabytes. Then we've got what I call the diet period, where everybody was taking care of it. It was the period where, are we gonna lose the GitLab instance or not? And then beginning of July, people don't really care anymore. It's not a big deal. We are monitoring things and we are checking whenever. So if suddenly on Ash Free Desktop or some admin asks you, hey, why are we using that many registry usage? It's because we are monitoring it and we are taking the right decisions depending on whether or not it's a good thing. So that's fine. It has a good impact. So if you remember, we had for cloud storage, we had registry and artifacts, and now it's time to look at the artifacts. Why had we so much artifact pool and traffic? The reason was because nobody cared about it before, and we were just using it. Yay, it's free. Let's use it. It was actually not free. So what happened? I would like to send a big thanks to the artifact project user, being Mesa and JStreamers. All of the people involved in those two projects. Thank you a lot. Because we went from 3.5 terabytes a week to a steady 150 gigabytes a week. So thank you. That is great. I know that it has been a very difficult effort, and yeah, thank you for that. So now that we've tackled on the cloud storage issue, can we do something about the compute engine? So if you remember, we are talking about networking, so it's cloud infrastructure to the rest of the world. We're not talking about how the compute engine works or what. However, before I go too deep into that, I have to give you small definitions for the cloud, because sometimes people get lost in what I can say about that. The first thing is that you'll often see on the web Kubernetes written as K8s, K8s. So that's just a thing to know. So in Kubernetes, Helm is a tool which is used to deploy applications, and the definition of the application is called a chart. So that's a very common tool to deploy on Kubernetes, because otherwise you have to manually write a bunch of YAML files that change over time, and it's kind of hard to distribute them and so on and so forth. We already saw the next three words, which are egress, ingress, node. So egress, if you remember, is the data going from the compute nodes to the client, download. The ingress is the other way around. So data going from the client to the compute nodes is the upload. The interesting bit is that the ingress is where you actually set up the rules of, hey, I'm going to talk to the registry, or I'm going to talk to the GitLab instance, or to the Git SSH instance. So of course, I'm talking about nodes. What is a compute node? It's a machine within the cluster running one or multiple pods. So it's either a VM or a bare metal machine. And a pod is, of course, a set of containers running in the same isolated environment. So for our free desktop GitLab installation, we would have pod running PostgreSQL. We have a pod running Nginx proxy for dealing with the ingress. And we have a pod running GitLab. So as of March 2020, the situation for the compute was not great. We are actually running an old deprecated chart with outdated components. The reason was that GitLab provided this chart to us at some point. And then suddenly, not suddenly, but they rewrote the whole thing into the Kubernetes native chart, which is much better. The problem of this native chart is that it doesn't have the pages component, which is where you can actually provide website directly from the CI. And on free desktop, we are using it extensively, so we can't really move away from this chart without losing that feature. So the problem with the updating component within the chart itself was that the Nginx proxy, the one responsible for the ingress, if you follow the previous slide, was returning the local address in the logs. We are also using a soon-to-be deprecated API for Let's Encrypt SSL certificates. So if we didn't do anything, we would have to remove the HTTPS in the address of free desktop. That would have not been good. And we are still running an all-in-one GitLab Omnibus install, which is basically that you need to have a big machine to run it. For the record, we are still requiring 50 gigs of memory just for running the GitLab instance. I mean, just one container with everything in it. And that means that we cannot split the service across several nodes. Though on the plus side, I can't say that everything was dark. We still had an external PostgreSQL, so we could migrate this one without downtime or a small downtime window for anybody. We had external Redis, which is a tool used in Kubernetes for key value storage. Nginx and encrypted data definitions were also outside, so it was not that bad. So we have taken some steps. First thing was to update Nginx. If you have local address in the logs, that was not good. So we upgraded it. It was almost seamless, except for some people who were still written their old IP address. But now in the logs, we do have true IP addresses. So that's good. We can do something about it. So once we had the true IP addresses, we can try to do something with the tool that we have. And the tool that we have is called Prometheus. It's a tool that on Kubernetes that does some metrics scanning and everything. And so one solution was to rely on some fancy domain addresses and say everything that goes out to the CI forms would actually use a different domain address than all of the rest. So that's why if you have had a careful look at the GitLab logs at some point, you would see that you are using some GitLab packet new DFS freedesktop.org or GitLab snr freedesktop.org. This was just us trying to monitor the thing and trying to understand who was actually putting what. The problem is that we knew that Packet and Etsnare were pulling a lot of Git traffic, but we didn't know which project were actually used and if we could do anything about it. So it didn't work as much as we wanted. And so step 3 was to write another script to parse the logs, of course. And now we know which project and operation is using data. And this is what we get. So if you have a look at the graph, you'll see that basically everything that we are paying for regarding the compute engine is Git data, coming both from the rest of the world and the CI farms that we are administering. That's a lot, and that's something which is not very good. So the total there on the right is for the whole period of between June, when I started the script, and till last week or something like that. So it's still less than the registry, but it's still not good. So what is Git usage from the internet? There is a bug in the Git transport protocol v2 that has been reverted upstream. I'm not sure if it has been fixed or not. But basically, if you do a Git pull with the stock Git install of Fedora 32, for example, of the Mesa tree, instead of pulling just a few kilobytes, you would pull the entire clone repository, so 200 megabytes. There's a bug. The problem is that we can't detect it on the server side, and we can't do much more besides telling people, hey, please do not use that, because it just costs us a lot. From the CI farms, now that we know which project does what, we can actually pull the graph. And when we pull the graph, we realize that there is a big problem with the Mesa project. The Mesa project is using Git and CI extensively. That's good. The problem is that the runners and the project itself were not using cache at all. And every time the jobs were running, they were doing a full Git pull. And so you end up with a 4 gigs pull just for one pipeline. So the Mesa developers did some steps to prevent that, but the biggest actually remediation that we made was actually to provide a Git cache. So what we did was that we installed on packet file server with a cloud file system API, so a F3-like API, which is called min.io. We changed the runner configuration to execute a script before pulling the Git tree. That was a tip that was given by GitLab, thanks to them. And then we also changed the GitLab CI YAML file to use a cache version of the tree. So what it does is that every day we regenerate the cache, and whenever we don't find the cache on the job itself, we just pull that tarball, extract it, and then we just download a few kilobytes. That was very easy to set up for the project, and it's very it's useful. And also, this is something that can be done for any project. So if you are worried about putting a lot of Git data or a lot of Git bandwidths, we have this min.io server that anybody within PrestaStaff can use, and we can explain to you how you can actually make use of it. Or being that for the artifacts, you can also use that for the artifacts. It's really easy to set up. So what now? Where are we and why we are in a better shape? So if we take the numbers on where we are, so I don't have the numbers for September, of course. We went for more than 6,000 a month to a regular 3,000. And the regular 3,000 is mainly because there is a hard limit of 2,500 a month just for the infrastructure. So that's good. That's not enough to my mind, but we managed to reduce the cost and at least to stop the growth of the cost. So we are monitoring things, and we are definitely within the expectation, or at least we refine the expectations. And this is something that we can sustain. Though we are still burning money on Google Cloud for things that might not be useful, so we need to do something more. So what can be done? The first step, and the first step is to continue the modernization of our GitLab installation. We had a all-in-one omnibus installation, and we are migrating to the native Kubernetes chart. What has been done so far is that the registry has been pulled out, which means that now whenever we do a config change on GitLab, the registry stays up, which means that your CI job, if it's still running, or if you need to pull something from the registry, you might not have downtime while doing this operation. So that's a win. Also, the other thing is that we now are able to put the registry in read-only mode for a certain period of time and running a garbage collection and delete all of the images that are not used anymore. In progress, and that's something I started 2-3 weeks ago, and it's still in progress because we still have a bug. is the web service chart. Once we manage to get the web service chart outside of the GitLab Omnibus installation, we will be able to do upgrades without downtime. That would be really nice for everybody. But there is a bug that we can't figure out what's the problem. And once the web service is out, my plan is to move out Gitali, so the Git server, Sidekick, which is a task runner in the background, and task runner, which is the backup pod, and so on and so forth. And then once we got this set up, we can actually move out from Google Cloud and put things in different places instead of having everything in our Google Cloud Compute platform. So I would like to thank GStreamer, the GStreamer Foundation, the Streamer folks for paying half of our CI runners. So whenever you see a Hetzner runner, that's GStreamer who is paying for you. So that's a big thank to them. Also, I would like to thank Packet, the company who sponsor a lot of our CI. The rest, all of the Packet runners are actually paid by Packet or hosted at Packet. And that's very, very nice of them to help us. Last but not least, Packet offered to host our GitLab infrastructure, and this is something that we have in mind. It will take a little bit of time. We need to move piece by piece without having to rely on some downtime. So, but yeah, thanks a lot for them, and hopefully we will be able to reduce the bill even more. So I've got a few takeaways. The main thing is that as soon as we had Grafana, this helped everybody to know what was going on and to help us monitoring the state of the current installation and monitoring the actual cost. So Grafana was great. It's integrated with GitLab, so that's really nice. What didn't, for the past 6 months, the default metrics tool were not matching our needs, which are basically we want to have a per project match, not just a global on the instance level monitoring. And last but not least, I've got a few advice for projects. If you want to help us, do not rely too much on artifacts, please. If you have big artifacts and that you are reusing and you want to have caching, please use Min.io for storing data. Ask us on Ash FreeDesktop. It would be really easy to set up. You don't have to. It works very well with forks and whatnot. Also, please use CI templates. The URL is there. As soon as you need a custom image, which means all the time. Because when you use CI templates, basically, you are also setting the various labels that help us for our Docker free space script. So that's what I have. Now I'm open for any question, if you have any.
So I didn't see any questions on IRC right now. There's just general sentiment that people are very thankful for you, like for your work on free desktop.
Thank you. I mean, I must say that also. Like, so Daniel and Michel are also there on the stream, and they have been really helpful in all of the work that has been there, being in Mesa project or in all of the infrastructure. So thanks to them too.
Yeah, so you're aware, I just switched to a tiled view so we can see all three of you on the stream.
Okay, cool. So,
yeah, if there are not any questions, thank you again, and that would be it.
Thank you.
Goodbye.
Goodbye.